Okay, hello Cloud Gurus and welcome back. In this lecture, we're going to look at NAT instances and NAT gateways. I almost don't want to teach NAT instances because they are on their way out. NAT gateways have come in to solve this issue. But as you remember, in the last lecture, we had our little MySQL server and we want to go in and do some updates and install MySQL on it, but we have no internet connection. And what we don't want to do is put it in a public subnet because we want to be protective of this server. So I'm going to show you NAT instances first. As much as I hate NAT instances, they are on their way out. Unfortunately, they still are mentioned in the exam, so you have to understand what they are just at a very high level, and then we'll look at NAT gateways. So let's log into the AWS console. Okay, so I'm logged into the AWS console. I'm going to go over to EC2, and I'm going to go ahead and launch an instance. So a NAT instance is exactly that. It's an instance, and we basically can get them from our community AMIs. If you just type in here NAT, you'll be able to get a NAT instance. I'm going to use the very first result. So it's an Amazon AMI VPC NAT instance. It's a HVM virtualization, and it all looks good to me. So I'm going to go ahead and hit select. I'm going to use a T2 micro and go ahead and configure the instance details. I'm going to leave everything as default, except I'm going to obviously put it into my VPC. So I'm going to put it into A Cloud Guru VPC, and I'm going to put it into my public subnet. So it needs to go in 1.0. Next, I'm going to add my storage, add my tags. I'm going to add this tag, and I'm going to give it a name, and the name is just NAT instance, something like that. Make it very prominent. Next, I'm going to configure my security group. This needs to go into my WebDMZ security group, which has HTTP access enabled and SSH. I'm going to go ahead and hit review and launch. Just notice that that security group that I've got there doesn't have HTTPS enabled, and we will need that, especially if we're going to go download MySQL and other things, because it does it over HTTPS connection. So I'm going to quickly fix that. I'm going to go ahead and launch. And then it's going to be using a key pair that I have access to. So go ahead and hit launch. And like I said, I'm just going to quickly fix that issue that I've just noticed on my security group. So my WebDMZ security group in here. I just go down to my inbound ports and I don't have access to HTTPS, which I definitely need access to. So I'm going to add that in. And there we go. And yeah, for both IP4 and IP6. So that is done. Next thing I'm going to do is just go over to my NAT instance. We don't need to log into this NAT instance at all. One thing I do need to do though is I need to go to actions, go over to networking, and I need to go ahead and change the source and destination check. So why do we do this? Well, if you read the documentation, it says each EC2 instance performs source and destination checks by default. This means that the instance must be the source or the destination of any traffic it sends or receives. However, a NAT instance must be able to send and receive traffic when the source or destination is not itself. Therefore, you must disable source destination checks on the NAT instance. You only need to do this on the NAT instances and not on the NAT gateway. So I'm going to go ahead and disable it, and there we go, it has now been disabled. The next thing I need to do is go over to my VPC and I need to create my route. So I go over to my route tables in here. Now what I want to do is I want to have a route out from my default route table via my NAT instance. So I need to go in here and add another route, and then the destination is just going to be o.o.o.o/o, and in here, now I'm not going to select my internet gateway because that would make my route table, my default route table, and all subnets associated to it public. I'm just going to click on my NAT instance and go ahead and hit save. That has now added a route out via my NAT instance to the outside world. So let's go and log into our public instance and then log into our private instance. Okay, so I'm here and I'm in my public instance. You can see 10.0.1.242. And what I want to do is I want to SSH EC2 and then -user and then and then I want to go over to 10.2.143, and then I'm going to be using the key, and I've actually forgotten the name of it, so I'm just going to hit enter and then just type in ls saved in here. So it's mypvk, so mypvk.pem, and hit enter. And so now I've been able to access my my private instance. I'm going to elevate my privileges, clear the screen. Now I'm going to run a yum update and -yes. And there we go. It is now updating, so it has internet accessibility. So what do you think would happen if my NAT instance died? Let's go back over to the AWS console. So here's my NAT instance. Now, of course, this has, it's got a ton of bottlenecks. Basically, this is a single instance in a single availability zone. It's only going to have so much network throughput because it's a T2 micro. As my estate gets larger and larger, I'm going to have to scale. I'm relying on a single operating system. So if anything crashes with that, I'm going to lose my internet access for all my servers behind in my private subnets. It really is not a good way of designing it. Yes, you can put in auto scaling groups. Yes, you can have them across multiple availability zones and have multiple routes out to the internet, but it all gets very, very complicated. So thankfully, Amazon released the NAT gateway last year, and the whole idea is to automate a lot of that and to get rid of relying on single instances within single availability zones. So what I'm going to do now is just go over to Actions, and I'm going to go ahead and terminate this instance. So go ahead and hit terminate. Yes, that has now killed off my NAT instance. Okay, so that's now terminated. I'm just going to Alt-Tab over to my terminal window, and I'm going to go and say yum install MySQL -yes. And you can see here I'm having all kinds of errors because there is no route out to the internet right now. So I'm going to hit cancel. So the next thing we need to do is we need to go back over to the AWS console. Here I am in the AWS console. I need to go back over to VPCs. So VPC is under networking. And then what I want to do now is I want to go ahead and create a NAT gateway. Now there's two things. NAT gateway operates on IPv4, and then we have egress-only internet gateways, which operates on IPv6. I'm just going to do NAT gateways for now. I'm going to go ahead and create a NAT gateway. In here, if you click in your subnet, make sure you select the public subnet in your custom VPC. In here, we need an elastic IP address in order for this NAT gateway to work. Just go ahead and hit create a new elastic IP address and then hit create a NAT gateway. Now you'll see this little button that says edit route tables. You can go and click on that, but bear in mind that it's going to take you about 10 or 15 minutes for your NAT gateway to actually be provisioned. So I wouldn't click on it yet. I'd click on close and then just wait until, and go over to the NAT gateway landing page and wait until you see it's available. So I'm just going to pause the video. Okay, it's now available. Actually, I just want to show you something really cool. There's a little notification up here on open issues. It's very, very rare to see this. And you can see that they're having some issues with code build inside US East 1. So they are now sort of alerting you via the dashboard. I haven't seen this in basically ever since using AWS, so it's pretty cool. So coming back to my NAT gateway, so we can see my NAT gateway in here. It is now available. What I need to do is go over to my route tables. In my route table here, I need to go over to the route, my default route table, which is in my subnet. I can see in here. And then right now, we're going to have this black hole because the ENI has been deleted. It can't see that anymore. So we want to go in and change that anyway. Let's go and remove this rule. So I'm going to add another rule. I'm just going to go to o.o.o.o/o. And then the target is going to be this NAT gateway. And then we're going to go ahead and hit save. That will now save it, and we should now have a route out. Let's go over to our EC2 instance. Okay, so I'm on my private instance. You can see it's 10.0.2.143, and maybe I want to install Apache, something like that. So we could do yum install httpd and then -yes. And there we go, it's downloaded and installed it. So it now has internet access. If you type comparison of NAT instances and NAT gateways into Google, you'll find Amazon's documentation on it. In terms of availability, NAT gateway is built to be highly available. So you're going to need NAT gateways in each availability zone. Do bear that in mind. It's not good enough to just have one NAT gateway in one availability zone, because if that AZ goes down, you're going to lose access to it. But you do want to have multiple NAT gateways across multiple availability zones. You just need a route out in your main route table to each one, and then failover will happen automatically. In terms of a NAT instance, you have to basically go in and configure a script. You need auto scaling groups. You need to watch the bandwidth on on the instance, because it's it is a single virtual machine. The bandwidth here on a NAT gateway is supported up to 10 gigabits per second. Scroll down, have a look at all the different things, but essentially, NAT gateways are much more preferred than NAT instances. One thing they do point out here, though, is you can use your NAT instance as a Bastion server. Bastion servers are not supported with NAT gateways at the moment. Bastion server is just basically a server that you use to RDP or to SSH into instances that are in your private subnets, and you can do that either via the terminal window or by using PuTTY, and then you don't have to store your private keys on your public instances. You can store them on your client devices. So yes, again, I'm going to call this out. I should not save my private key on a web server that's accessible to the public, but I'm just using this as an example. I'm showing you how gateways work. Okay, so let's look at how this looks from a network diagram point of view. So we've got our NAT gateway. It sits inside our public subnet. We could have multiple NAT gateways across multiple public subnets for redundancy. If we did do that, we need to make sure our route tables were updated so that we had routes out to multiple NAT gateways. The cool thing about NAT gateways is that they're not a single instance that can go down and fail. They're basically some sort of clustered instance that Amazon manage for us. We don't have to worry about patching the operating system or antivirus or anything like that. Amazon take care of it all for us. Also, the important thing to realize is NAT gateways, basically don't sit behind a security group. When we created our NAT instance, we had to place that in a web DMZ security group. So it's basically more or less over here. So NAT gateways are fantastic. You should use them all the time, to be honest, instead of NAT instances. NAT instances are a pain to manage, but unfortunately, NAT instances still come up in the exam. As much as I'd like to throw them into the dustbin of history, I have to teach you about them because they are an important exam topic. So what are my exam tips on NAT instances? Well, when creating a NAT instance, make sure you disable the source destinations check on the instance. Remember that NAT instances must be in a public subnet, and there must be a route out of the private subnet to the NAT instance in order for this to work. And the amount of traffic that the NAT instance can support depends on the instance size. If you are bottlenecking, make sure you increase the instance size. You should not be using T2 micros for NAT instances in a production environment if you're going to need gigabits of bandwidth out. You can also create high availability using auto scaling groups, multiple subnets in multiple different availability zones, and scripts to automate failover. That's if you want to use a NAT instance, though. Also remember that NAT instances are behind a security group. NAT gateway, they're way much preferred by businesses and enterprise customers. They scale automatically up to 10 gigabits per second. There's no need to patch, no need to worry about security groups, no need to worry about antivirus either. It's all managed by Amazon, and they're automatically assigned a public IP address when you go in and create them. Remember, they can take 10 or 15 minutes to create. Always remember to update your route tables and to point them to the NAT gateways. Remember, having one NAT gateway in one availability zone is not good enough. You want them in multiple availability zones so that you have some form of redundancy in terms of availability zone failure. And there's no need to disable source destination checks on a NAT gateway. And then finally, NAT gateways are far more secure than NAT instances. You do not have SSH access to your NAT gateway. You don't have to worry about patching the operating system. You don't have to worry about antivirus. Amazon go in and manage it all for you. So you'd always want a NAT gateway than over a NAT instance. So that is it for this lecture, guys. In the next lecture, we're going to start looking at security groups and network access control lists. So if you've got the time, please join me in the next lecture. Thank you.